Okay, here we go. Final video of the year and our final topic, the zero product property, and then how that ties into solving what are known as quadratics. So, starting off, the zero product property says that if you have a product of two numbers that are being multiplied together and you know that that has to equal 0, well, then the conclusion is that either A would have to be equal to 0, or B would have to be equal to 0, or it's possible that both A and B would be equal to 0. And those are the only outcomes that are going to produce a product of 0, so we can conclude that it has to be one of those. So we can use this concept to then write an equation that consists of a set of products. The equation will likely have more than one solution as well. So here we have our binomials being multiplied together, but this time, instead of just having the binomials multiplied together, we know that it has to equal 0. And so using the same logic as what we just had from up above, if A times B has to be equal to 0, then either A or B is 0, or possibly both A and B are 0. Well, if this is factor A now, instead of just being a number, it's a little expression, x plus 3, and this is factor B, x minus 5, then either one of those things, if we can make either one 0, then we make the whole thing 0, because they're being multiplied together. So what that means is either x plus 3 would have to be equal to 0, or x minus 5 would have to be equal to 0. And then what I can do from here now is just solve for what x is equal to in each of these. There's little one-step equations. For this one, I can subtract 3 from both sides. I get that x is equal to negative 3 for that one. Over here, add 5 to both sides, and x equals positive 5. So, if I either make x equal to negative 3 or make x equal to positive 5 in these, if I were to do that, I have to just choose one or the other, which means like if I use negative 3 for x, then this is going to be negative 3 plus 0, which is going to make 0. This is going to be negative 3 minus 5, which is going to make negative 8. But negative 8 times 0 is going to equal 0. If I make both x's 5, and I substitute a 5 in, then 5 plus 3 is going to be 8, times 5 minus 5, which is 0, and 8 times 0 is equal to 0. So this shows me that I can either have x be equal to negative 3, or, and instead of writing the word or, what we do in math is we put a little semicolon, it can be 5. Now the reason we don't use a comma is because then it looks like a coordinate, so we put a little semicolon in between to show that it can be either one of those numbers. Okay, for number 2, same idea. The 2a plus 4 is one of my factors here. A plus 7 is my other binomial factor. The fact that those are set equal to 0, either one of those can be 0 and it'll make the whole thing 0. So if I set up a couple of equations, the first one can be 2a plus 4 will be equal to 0. A plus 7 could be equal to 0, and then solve each of those. The first one's a little two-step equation, so I first have to subtract 4 from both sides. I get 2a is equal to negative 4. Divide by 2, and one possibility is that a could be equal to negative 2. Or, over here for this one, subtract 7 from both sides, and a could be equal to negative 7, so a could be equal to negative 2 and or negative 7. Okay, one more. So same idea. I could have 3t plus 5 be equal to 0, or t minus 3 equal to 0. Subtract 5 from both sides here first. 3t equals negative 5. Divide by the 3. And t equals negative 5/3. Or add 3 to both sides over here. And t equals positive 3. So t could be equal to negative 5/3 or positive 3. Okay, so that's the idea of the zero product property. If you have two things being multiplied together and you know it has to equal 0, well then either one of those two things can be 0 and it'll make the whole thing 0. So using that concept now, we're going to be solving what are called quadratics. So quadratic, what a quadratic is when you have an x squared term in your equation or in your function. By having that, what that creates is that U-shaped parabola graph that we talked about earlier in the year, and those are known as quadratic equations. Anytime that x squared or your variable is squared and that shows up. So linear equations are what we call them for the ones that make straight lines that we've been focusing on for the entire year. But if it has a squared term in it, then it's quadratic. So anyways, number one here, set the equation equal to 0 first is what we're going to have to do. So if it's not already set equal to 0, we have to get it set equal to 0, which means moving all the terms to one side, basically. And if we move all the terms to one side, then we get the equation set equal to 0, and then it'll be set up to have the zero product property come into play. For number 2, we then need to factor the equation. And by factoring the equation, that's what we practiced last week. So that's where we're going to identify A, B, and C. We're going to make our diamond, and we're going to factor it into two binomial factors. Unless it's already done that way for us, like it was up above, where we had the binomials already. And then we're going to set each binomial equal to 0 and solve the resulting equation just like we did above. Okay, so for the example here, number 4, we've got x squared plus 15x plus 30 is equal to negative 6, and so it's the x squared term in the equation here that makes this a quadratic. I'm going to first need to set it equal to 0, so I don't want to do any factoring until I have it set equal to 0. So in this case, to do that, I have to move this negative 6 over to the other side, so it joins all the rest of the terms there, and I can do that by adding 6 to both sides. Remember, I can only add 6 to the other constant, which is 30 in this case, so I can't add it to the 15x or the x squared because those aren't like terms. But by doing that, it's going to get rid of everything over here and make this side 0 like I'm wanting. Over here, everything stays the same except for adding 6 to 30, which is going to make 36 there. So now I have this trinomial, right, like we practiced with last week. It's a quadratic, though, as well, because its highest power term is a squared term. So x squared plus 15x plus 36. I'm going to factor that now. So A, B, and C, 1, 15, and 36. I'm going to make my diamond. Remember, C goes on top, or it's actually A times C on the top, but in this case A is 1, so just C on the top. B on the bottom. Figure out what multiplies to make 36 and adds to make 15. Well, let's see, we've got 6 and 6, but that's going to add to make 12. We've got 9 and 4. How about 12 and 3? So 12 times 3 makes 36. 12 plus 3 is 15. Now I take my factors that I got from those and turn those into my binomial constants. So it'll be x plus 12 and x plus 3. And that's now equal to 0, right? Because all I did was just factor this side, which means changing it in from a trinomial into a product of two binomials. And by doing that, it's still going to be equal to 0 on the other side. And now I can write my two equations. So I can have an x plus 12 is equal to 0 and an x plus 3 is equal to 0. Solve each of those. But what you'll hopefully come to realize is it's really just the opposite value of the constant that you have in the binomial, right? Because all you're going to be doing is just adding or subtracting it to the other side, and what we're going to always have on the other side is just 0 there. Now there will be some next year with Algebra 1 for you where you have this maybe a coefficient with the variable term, but since I'm making all of our a values just equal to 1 for these ones, I'm just again trying to kind of give you the surface level description of these. It'll be pretty consistent that it'll just be the opposite sign value. Okay, so what we end up finding is that x can be equal to either negative 12 and or negative 3, And by putting either negative 12 or negative 3 into this equation for x, I'm going to get negative 6 when I simplify this side. Right, so if I did negative 3 in there, negative 3 squared is positive 9. Plus 15 times negative 3, that'd be negative 45. And by adding 30 to that, that'll make negative 15. But then adding the 9 that I had here to that would make the negative 6. So that's how we solve a quadratic. Okay. For number 5 here, I've got x squared minus 15 is equal to 2x. So I want to move this 2x term back over to the other side so that I can get it set equal to 0. So to do that, I'm going to subtract 2x from both sides. Over here, I don't have just an x term to subtract it from. So I'm going to write it as minus 2x there, but I'm not actually going to be able to subtract it from anything. So it'll just stay as x squared minus 2x minus 15, but now is equal to 0 like I'm wanting it. Okay. Now I need to factor this side. So a equals, b equals, c equals 1, negative 2, and negative 15. Diamond with negative 15 on the top, negative 2 on the bottom, and let's see, 5 and 3. But in order to end up with a negative 2 when I add them together and to multiply to make a negative 15, I'm going to have to make that 5 negative. So that means I can have x minus 5 be equal to 0. No, sorry. That's my back up. Try this again. We got to turn those into our binomials first. So those are not your answers to what x is. It's actually going to be the opposites of those, right? So it's going to be x minus 5 and x plus 3 is going to be equal to 0. And now from that, I can write my two equations, which means from this one, when I add 5 to both sides, I'm going to get x is equal to positive 5. Over here, when I subtract 3 from both sides, I'm going to get x is equal to negative 3. So x can be equal to negative 5 and or, no, positive 5 and or negative 3. Sorry, kind of got lost in my, went too quickly on that. So the numbers you get from the factors in the diamond become the binomial constants. We then need to set the equations up and solve for those, but it's going to be the opposites of the numbers that we got from the diamond, right, are going to be in our answers. So if I got negative 5 in the diamond, notice that I got positive 5 here. If I got positive 3 in the diamond, notice I get negative 3 here. Okay, column questions, if you want to go over there and answer those, just to stay in practice with things, good idea. I'll put the answers to those in the completed copy of the notes online. Same thing with the conclusions here. So jumping down to the summary to go over that here real quick. So explain the zero product property. So if two numbers or expressions multiplied to make 0, then one or both of them have to be 0, right? So it's the A times B equals 0, then either A or B or A and B have to be equal to 0. Okay, explain what a quadratic equation is and provide an example. So the variable term is raised to the second power. Okay, in the equation, an example of that, we could have something like x squared plus 17x plus 30 is equal to, and you don't have to put 0 here, you could do any kind of number. You could have 15, 17, negative 3 even, or you could have even another like a y over there, and that would still be considered a quadratic equation. Okay, and then solving the following equation, summarizing each step as we make it. So we've got x squared minus 12x equals negative 32. So first things first, I have to set it equal to 0. Right? So okay, so set equation equal to 0. Again, to do that, I move any terms that are by themselves on one side over to where the rest of the terms are at. You don't necessarily have to move everything to the left side. It's fine to move everything to the right side as well, as long as it's set equal to 0. So we've got x squared minus 12x plus 32 then will be equal to 0. I had no other constants on that side to add it to, and they're not like terms with the others. Okay, step 2, after we get it set equal to 0, is factor. In this case, it's a trinomial. It could be just a binomial that you have to factor. If you're missing one, like the b term or possibly the c, then you might need to factor just that. But again, to factor, I identify my a, b, and c values. So a is 1, b is negative 12, c is 32. I make my diamond, c on top, that's 32, b on the bottom, negative 12. So that would be 8 and 4. But in order to make a negative 12 on the bottom, they're going to have to both be negative, but by both being negative and they multiply to make a positive 32 on top. I then can turn that into my binomial products. So x minus 8, x minus 4, now equal to 0. And then step 3 is to solve well, actually, step 3, this should actually probably be step 4, so step 3 should be set each binomial equal to 0, and then solve each equation after that. So we're going to have an x minus 8 is equal to 0, and an x minus 4 is equal to 0. Add 8 to both sides on that one, add 4 to both sides on this one, and we get that x is equal to 8 from this one, x is equal to 4 from this one, and so x can be either 8 and or 4, and it will solve our equation, right? But again, just because the fact that we have an a value equal to 1 on these ones, notice that it's just the opposite numbers of these factors here that I got in the diamond. Alright, so the goal for today was just to complete the notes, so maybe go back and complete the conclusion questions if you haven't done so already, and do the column questions and then check those. Tomorrow the worksheet will be up for this, and then Wednesday of this week the quiz is coming out, giving you guys a few extra days to get that finished, or an extra day to get that finished, just because Friday is going to be the last day for work. So good luck on this week.